everybody. My name is Brianna, as per usual, and welcome to week 2, episode 2 of Kitchen Chemistry. I am back in my kitchen, and we have a bit of a theme today, sort of reminiscent of my outfit. We are going to be talking about one of the core vegetables near and dear to my heart, because it carries me through science and working through science venture. It is the humble red cabbage. I have several in my fridge. This little fella here, tasty. I ate some last night because I bought an absurd amount for this. And B, can be used for all kinds of experiments. And today we are going to be using this little cabbage here, and some other cabbages, to make some pH indicator, to learn about pH, acids and bases, and to make a rainbow. So we're having a purple day, which I was excited about. So, first things first. Just like last week, we want to make sure that everyone's being safe. So if you choose to do any of the things I'm doing in the video today, I want to make sure we are protecting ourselves, we are protecting our environment, and we're protecting each other. So we always want to protect your clothes, wear a lab coat, gloves if you feel comfortable with them, goggles, or I wear my glasses. And we're using a lot of more acids and bases, and we always want to be careful with those because acids and bases, if they're strong enough, can burn you. And also we wanted things to be well ventilated when we're using different chemicals. So like I'm in my kitchen, so I have all the windows open. You can hear my neighbor lawn mowing periodically, but you know, the things we do for health and safety. So just make sure we're all being safe, because that's all I ask. Because I don't want anyone to hurt themselves. We're also using the stove today. Humble, my Costco kitchenware is coming in handy once again. And there's the possibility that you might use knives for this, so always ask an adult for help if you are a little younger. So, what are we talking about today besides cabbages? We are going to talk about pH and acids and bases. What are acids and bases, you ask? I'm glad you asked. So, acids and bases are two categories of substances that have different properties. At their core, acids are chemicals that donate hydrogen. So when we add them to like a solution with water, a solution, definition time, a solution is just a chemical or a compound added in with dissolved, mixed in with a solvent. Solute, the thing you're adding in, solvent, the thing you're mixing it into. So today we're going to be using different acids and bases as our solute. We're going to be using water as our solvent. It's going to be our solvent all the time because everything we're doing today, it's all stuff from my kitchen and to my house in general. I redid the laundry room. So acids in solution donate hydrogen. They spit them out, they dissolve, the chemical breaks down, and puts hydrogens in the solution. And the more hydrogens there are, the more acidic the substance is. Whereas on the flip side, bases are hydrogens acceptors. So when they are in solutions with hydrogens in them, they take up these hydrogens. So acids give the hydrogens, bases take them up. And that's why when you add an acid and a base together, they react, because the acid is giving off these hydrogens, the bases are taking them in, and eventually they even out because the acid is giving off an equal amount of hydrogen and the base is bringing them back, and then they play pass back and forth. And that's why this solution kind of neutralizes out. So, a little complicated, I know. It's kind of hard when I don't have like a whiteboard or something. I'm working on it, but appreciate you bearing with me. So, acids and bases. Hydrogen donors, hydrogen acceptors. How do we measure this? This is a good question, because if we want to tell if something's an acid or a base, or if we find a mystery chemical in the lab and like someone hasn't labeled it in a shocking surprise, we have to be able to tell what it is. We want to know if it's dangerous. We need to know how strong it is, because just because something's an acid or a base doesn't tell me a lot of things. It could be a really weak acid, like something that, like, for example, there's lots of weak acids in fruit because they have citric acid in them. And things like coffee, tea, they're a little more acidic. So it could be a weak acid that's safe for us that we don't need to wear a lot of equipment for, or it could be a super dangerous acid that could burn my skin. Or on the flip side, bases can also burn you if they're strong enough. You don't want to be mixing with that. How do we test? We use something called an indicator. We're actually going to be making one today with our friend the cabbage. So, an indicator is a substance that changes color in response to if it's put in an acid or base. So some indicators have a wide range. So some indicators, put that down because I know I'm going to chuck that cabbage. I'm going to chuck it, I'm going to drop it, it's going to end up on the floor, it's going to be a hot mess. Some indicators have a wide range. So they will change color. For a strong acid, they'll have a different color. For weak acid, for neutral, so either not acidic or basic. And then they'll have a bunch of different colors for how basic it is. Some of them just are a smaller range. So they might be able to tell you if something's acidic, basic, or neutral, but it can't really tell you how acidic or how basic. So those could be good to kind of give you ballpark ideas. Things like litmus paper, some basic litmus paper, are just like little strips of paper you can dip in, and they'll often turn red for acidic or blue for basic. Then there's ones that can go in tighter ranges. So maybe once I figure out, oh, this is an acid, this is base, I can use these kind of indicators that give me like some just tell of something, how acidic something is, or some just go on how basic something is, or a little bit over on one side, a little bit in the middle. And we measure how acidic or how alkaline, another word for base is alkaline, acidic or how alkaline something is based on the pH scale. pH scale, it's just another unit of measurement, and it goes incrementally by 10. So it goes from 1 is the most acidic, and then we have 14 is the most alkaline or basic. And then in the middle, we have 7, which is neutral. It's not really acid or base. Things like water is neutral. Whereas something like drain cleaner, something really basic, would be closer to the 14 end, and something like stomach acid or battery acid, that is closer to the 1 range. And each time you go to a lower number, that thing is 10 times more acidic. So something that has a pH of 6 is 10 times more acidic than something that has a pH of 7. And if I hop her to 5, it's 10 times more acidic than 6, etc., and going the same way the other way. So something that is 8, has a pH of 8 as opposed to a pH of 7 is 10 times more basic. So, without further ado, we are going to make a indicator of our very own using just stuff you can find in your kitchen, your grocery store. It's got 2 ingredients, cabbage, water. Pretty straightforward. So, before I get into that, why does the humble cabbage, specifically purple cabbage, why is it able to be an indicator? Well, last week we talked about why different fruits, vegetables, and different animals have different colors and how those coloring compounds work and how to dye stuff using those compounds. And one of the things we used, and I use specifically for my lab coat in the purple parts, is we use cabbage. And that is because cabbage and things like blueberries, blackberries, dark fruits, eggplant, they contain anthocyanins, anthocyanins, which are these dye molecules that make it nice and purple. And what these dye molecules actually do is when they are added to an acid, they change. They just flip one of their bonds, or they add on another chemical, or they take up that hydrogen, and it causes the structure from, let's say it's neutral, like my regular cabbage, it causes the structure to switch a little bit, and this turns it red. But then, or I add it to something basic and it'll switch a different way, which will cause it to be another color. And depending on how acidic it is, more of the dye molecules are going to be the acid colors, or more of them are going to be the base colors. Acidic, neutral, base. I told people I'd be dancing in the kitchen, so here you go. So, these anthocyanins in the cabbage are going to change color depending on if we add them to an acid or base and how acidic or basic something is. It's kind of hard to measure exact pH with this because this is not an exact science. I'm just going to chuck some cabbage in a pot and cook it. So it's not going to be exactly the same if you make it at home because it's really rough measurements. It's not very hard to do, but it's not the most scientific. So this isn't really something you use in the lab. But in my lab that is my kitchen, Use it all the time. Super easy. The great thing about it is you can also keep it in the fridge when you're done, or you can freeze it. I freeze it for months at a time. Wendy taught me that. Shout out to Wendy. So what we're gonna do, what things do I have? I'm gonna tilt this so you can actually see. I've got my cabbage and I've got my pot. This is a great way to get folks with little hands involved if you've got some younger kids at home that wanna help with some science. So first I have some dodgy leaves from the cabbage I ate yesterday. And all I'm gonna do is take these outer leaves from the cabbage and I'm just gonna rip them into smallish pieces. It's pretty easy to tear. Some of them are a little harder, in which case you might need to use a knife. Or even some kitchen scissors are a great way to do this. I say as I can't rip the cabbage on camera. You just rip it into some pieces. So I'm gonna rip these into the pot. I'm not gonna make too much for this because I already have some prepped. This is just to show you. So we rip some up and then I have about that much in the pot. Probably like a little less than a cup. So I'm going to take one more outer leaf off the cabbage. I cut the bottom off, the root, which makes it a lot easier to pull the leaves off because that's what they're anchored to. And see, it just peels right off. Again, some of the thicker leaves might be a little harder, but team effort. Of course, long blonde hairs. I wonder who those belong to. Ripping our cabbage, chucking it in the pot. This is the equivalent of me tying the knots in the tie-dye you all watched last week. So almost done. And they don't have to be super small either. We're basically making the worst cup of tea you've ever had in your life made with cabbage. So, covers the bottom of the pot. It's about a cup and a half. That's all you really need. Take my friend the cabbage, which is looking a little more disheveled. Pop it in the side. If you have leftover cabbage for this, coleslaw, delicious. I'm a big fan of pickled cabbage. You can make sauerkraut with it, whatever fruits you lose. I like pickles, so I pickle everything. Great way to use up leftovers. Maybe we'll even do some pickle stuff later on. We'll eventually do some recipes. So once I got my pot full of cabbage, I'm just gonna cover it up with some water. Have some water in the bottle. Gonna add a little bit more. I'm gonna add it from my sippy cup. I just like having a sippy cup on the side because I talk straight for half an hour. And you just wanna, it's same as last week, like it's not super complicated measurements. I'm just adding enough water to cover the cabbage. Now what I'm going to do is I'm going to take this, I'm going to pop it on the stove, and what I like to do, and this is just a thing from my stove, is I like to bring it, like if you're making rice, you bring it to a boil, and then you turn it down so it's just at a simmer, and I find that works really well. And you just need to cook it for as long as it takes for it to get like a dark purple, the liquid. The cabbage doesn't break down very fast because it's got lots of cellulose in it, lots of fiber in it. Good for you. So it'll take a while of stewing it to do that. So don't worry about that. You're just focusing on the liquid. Nice and dark purple. I made some earlier and it only takes me like 20 minutes-ish. It's not that hard. I'm gonna do that. Wow, I'm back already. I know, I'm such a speedy cook. Ignore the fact that my pot grew in size. I have some I made yesterday. So you end up, just so you know, it's gonna smell like you cooked cabbage in your house because that's what you did. So my house smells like cabbage. Last week it smelled like a pickle from all the vinegar. It's just how it goes. Sometimes science is stinky. So there's my pot full of cabbage. I'll take a little spoonful, just pour it out. So it's like, you can see it's a nice dark purple. It should just be the same color that the cabbage was. It does stain a little bit. Like this is very similar to how we made the dyes last week. Like I ended up with a little bit of purple fingers, but it's super washable. Washes pretty well out of clothes. Washes out your hands too. But if you're worried about it, wear an apron, wear gloves. This is why I wear a lab coat. It's like one big napkin I can wear. I love it. So don't worry too much about it. So now let's test the pH of some stuff. So part of the lesson plan, which I will have linked in the video after I post it, is we are going to make a pH rainbow. So you're just going to look at your house. What I did was I opened my fridge and I said, fridge, what do I have in there? And I had cabbage and a lot of condiments and some sparkling water and some really old lemons. The first thing I grabbed some lemons. I had tested them a long time ago. They've seen better days. So I have some lemons. Then I wanted to have some different solutions. So I also have coffee that I made yesterday that I forgot to drink, which is like very on brand for me. I have some baking soda to try. I've got a little bit of Windex. Anything with bleach in it that you're using, or this has a little bit of sodium hydroxide, this is not for small scientists. This is for nice adult scientists to use. And to make it safer, we dilute everything. And I'll explain a little bit more of that in a second. And I've got some laundry detergent, good old Tide, coming in clutch. So to set up our rainbow, I have this nice series of glasses. It kind of looks like I'm good. Oh no, I forgot about that one. We have a nice series of glasses here. And we're going to fill the glasses like a little way through with water. You don't need to use glass cups. I just did it so it's nice and easy for you all to see. But you can use plastic cups. You can use mismatched ones. I just use a nice fancy set for aesthetics in a shopping trip events. I like it when things look pretty. So we fill them about a third of the way, halfway full with water, because we're going to be making a bunch of solutions. So first thing I'm going to do this along with you. Nice, gross, wet lemon. Love that decision I made. I'm going to take this lemon and I'm going to squeeze a bunch of the juice into the water. Seed falls in, not a big deal. It's a lemon seed. We're not drinking this. None of the stuff we're doing today is for eating. So that lemon, I'm going to toss it in my sink. Then I got one more. I'm squeezing away. Again, it doesn't need to be really pretty. Normally I have a nice reamer for this, but it doesn't need to be rocket science. We are just squeezing a lemon after all for science. Toss the other one there. I'm going to give my hands a rinse because otherwise they'll be sticky. Good old tea towels. All right. Next thing I'm going to do is I'm going to add some coffee to this one. So it doesn't need to be a lot. It's a little tricky to see with the coffee for color, so this is why I do a solution, but you could just add straight coffee to the cup. You'll get a stronger color, but because it's so dark brown, it's hard to see the change. So I add it till it looks kind of like iced tea. That's the color we're going for. Next thing I'm going to do some plain water because I want to see what kind of color we have when we add to the water. Now I'm going to use a little bit of baking soda. I'm adding about half a teaspoon. I'm not even using measuring spoons for this. Just adding some. I might add a little bit more just for funsies, and you can give that a nice little stir. It doesn't dissolve super well, so it might settle a little bit at the bottom, so I recommend giving it a stir before you use it. We're going to add some laundry detergent to this one. Just a little bit. Again, some of these, if they're colored, it's a little harder to see the color change, but it will still work. Actually, no, I'm not going to use the Windex. I had two things I hadn't decided. I'm going to use some Shout It Out because it's clear, which has some sodium hydroxide in it, which should give us a good color change. So I'm squeezing out the nozzle. Got a little bit of that bad boy. Ew, it's kind of milky. Didn't know that. The more you know. I'm going to give my hands a little rinse because I got a bunch of stuff on them. Always wash your hands. So, to recap. Lemon juice, coffee, water, baking soda, laundry detergent, Shout It Out, some sort of bleachy thing. I'm going to give these a stir. Spoons are great for stirring. Forks are better. It's kind of like the poor man's whisk. I find it works great. I'll just use the same one for the Shout It Out. So you want to make a nice solution. So, what I'm going to use to pour out, normally I'd use something, it's my face and my very clinkly earrings. Normally in the lab or at Science Venture, I'd use like a pipette or something for that. But we're in my kitchen and I don't have any of those. The closest thing I have is a turkey baster. And I don't think my mother would forgive me if my turkey baster smelled like cabbage forever. So I'm going to use a nice little stainless steel measuring cup because it won't hold on to the smell. Most of the time, the smell isn't going to linger. It comes out pretty easily, but just in case, I recommend metal or glass because they're nice and inert. So I got my big old thing of cabbage indicator. I got my preset rainbow. Let's give it a go. So I'm going to take a little scoop. It's about a tablespoon and a half in here. You don't have to add all of it. But add it to my lemon juice. Whoa! Okay, that's exciting for me. So it starts out purple and it turns bright pink. A little bit more. A nice bright pink. That's awesome. Sorry. I get excited about science, can you tell? Actually, I'm still today, I get excited about most things, but you know, yeah, I do. So now let's add it to the coffee. Coffee's a little harder to see. Oh, there it goes. Turns a little bit red. It's a little harder to see, but oh yeah, you can see it there. It has turned red, kind of a darker red because the brown, but it's trying its best. Next, we have our water. See if it changes that much or at all. Yeah, it's kind of just the same purple as it was, which is showing us it's nice and neutral. Here, move the camera a little bit so you can see it better. Do a little curve. More curved like a rainbow. We're going to add some to the baking soda. Woo! It turns blue! Nice teal blue. We're going to add some to the dish soap. Ooh, that turned a nice dark blue. A smidgen more. And then last but not least, we're going to do the kind of bleach, Shout It Out. Shout It Out is just stain remover, so you could try other stain remover at home. And again, we have it turning a nice dark blue. So we have a little bit of a rainbow. So we have most acidic, it goes very pink, it's like a pink red. Slightly acidic turns red, neutral is purple. And I'm actually going to rearrange these because research has told me that it normally turns blue and then it turns green. And the more basic it is, if it's very, very basic, it can even turn yellow. But I'm not doing something like that today because it is dangerous and I don't want to do that in a lab. So I recommend you don't start messing around with things like Drano and bleach. I used things like stain remover or Windex because they are another solution. They're diluted, so they're less dangerous. So I recommend at home, if you're doing this, don't use a concentrated base. It can just burn you. It's bad news. The reason Drano acts as a drain cleaner is because it dissolves the hair or the gunk in your pipes. So don't do that. But theoretically, it does turn bright yellow. If I'm back in the lab at some point, maybe I'll post a video of it. But for right now, nah. So we have our nice little rainbow. So we can see how it turned out. So it's a little harder to see from your angle. If I swirl these around, the color's a little more visible. So purple was our neutral color. And then it goes more pink on this end and then more green towards the base again. So acids come out more pink, bases come out more green. And this is again because those anthocyanins, sorry, a little bit of a stutter. Anthocyanins change shape when added to an acid or base. So this is what I have for you folks today. We talk about acids and bases, acids being hydrogen donors. We talk about bases being hydrogen acceptors. We can measure if something's an acid or a base using an indicator, because an indicator gives us a rough estimate of the pH scale. pH scale is the scale we use to measure bases, and each number is increments by 10. So higher numbers are more basic, from going to most basic being 14, and least basic being 1. And then in the middle, with our water, was 7. So if you like the video today, you can let us know in the comments or on our social media. If you have any questions, shoot Science Venture an email. You can also comment on this video, any questions, and I'll get back to you. If you have any topics you'd like to see us cover later on, let me know. Comments, always helpful. Love your feedback. Really excited to do more of this. Next week, we're going to start doing some yeast. We're going to do a little bit of bread action. And we're going to start finally doing some cooking. So eventually, we will eat science, but only at home. So thank you so much for joining me for Kitchen Chemistry today. I am Brianna, and I will see you next week at 3 p.m. for episode 3. Goodbye, everybody. Takes a minute to end the stream.